Okay, kita dah live dah ni. Kita dah live. Sekejap lagi dekat YouTube dia akan keluar. Dia orang patutnya dah masuk dah tu. Tak apa sebab nanti boleh tengok balik. So, hari ni kita nak sambung untuk arithmetic progression Hari ni arithmetic progression. Oh, cikgu nampak dah tu. Ada yang dah ni. Arithmetic progression. So, kita akan mula dengan grup pertama, Christina dengan Ani Sofia. So, cikgu akan turun ke bawah. Christina boleh start lah. You duduk sorang-sorang dalam broadcast ni.
Okay.
Okay.
Okay. Assalamualaikum. Hi everyone. Today, I will be explaining inquiry 3, which the aim is to derive the formula of sum of the first n terms Sn of arithmetic progression. Okay, from last lesson, we have learned this formula, the formula to calculate nth terms. Let's revise a little bit. Tn equals to A is the first term, plus n, number of terms, minus 1, D is common difference. So here in the calculation, if we apply it in calculation, as given here, A equals to 5, D equals to 2. So just substitute the value, T2 equals to A equals to 5, plus N, 2 minus 1 times common difference, 2 equals to 7. Okay, for today's topic, we are going to learn sum of the first n terms. What is sum of the first n terms? So as if Tn is to calculate the value of these exact terms, sum of the first n terms is used to calculate the total of T1 plus T2 plus T3, which means here 5 plus 7 plus 9. So this is the point of sum of the first n terms. Okay. So now I would like to continue with the inquiry on page 133. I will start from diagram 3. Okay. So firstly, let's observe this diagram, the diagram given. There are 3 grids here, T1, T2, and T3. So what is it? What is important for us to calculate the sum of arithmetic progression? It is the value of the terms, right? So we are going to calculate the value of the terms using this formula. But roughly, as we can see here, T1 equals to A. T2 is D higher than A. And T3 is 2D higher than A. That's roughly we calculate the height of each of the grids. But here, I'll show you guys how is this formula is applied in calculating the terms. T2 equals to A equals to T1, plus N here, T2, and minus 1D. D is the common difference. Then we get A plus D. The same thing goes as T3. Now, to calculate sum of the first n terms, we are going to use calculating the area of rectangle. So as you can see on textbook, I will explain what is happening to the diagram. As you can see, T1, T2, and T3 was duplicated and were put on top of each other, forming rectangles. To be exact, 3 same rectangles. Okay, why do I say so? Here is the calculation to prove that all of this rectangle here, this rectangle here is the same as this here and here. This calculation I did to prove you guys that all 3 bars of the grid that was combined has the same height. Okay, here T1 plus T3 equals to A plus a plus 2d equals to 2a plus 2d. Well, T2 plus T2 equals to a plus d equals to 2a plus 2d. Well, this one is the same with this one, so it is concretely proof that all of them has the same size. To be exact, has the same area. This value can also be said as area because anything that was times by 1 equals to themselves, right? So now we are going to calculate the sum of the terms by using the area of rectangles. So as the first bar is equal to the other bars, so it is not necessary to know the value of other bars. We can just straight away calculate area of rectangle by calculating the sum of these two bars area, means that area of T1 plus area of T3 times by how many bars are they. How many bars equals to n, number of terms, as you see here. Number of terms, as you see here, 3. So it means there is 3 bars. Okay. Now, the sum of the terms is actually half of the area of the rectangle. Why I say so? Because we at the beginning we duplicated the bars, we duplicated the grids. So it means that the area of rectangles is total for a pair of T1, a pair of T2, and a pair of T3. So to find the sum, we must divide it by 2. Okay. So maybe you may ask why we don't just add multiply the value here that we already have. I'll explain to you guys by showing an example of more grids added. Okay. So here is the exact same pesusunan with the first diagram that we have. Okay. So as before, I calculated each of the terms, each of the grids value by using this formula. Okay, so here is the value obtained. Now, as you may ask before, why don't we just multiply them one by one? Here, I'll show you guys. This one is the calculation that I've done. I multiply it one by one, as you can see here. Now, let's compare it with the second method that we've learned before, where we duplicate them and so on. Now, let's see here. The same goes as before, the same goes as this diagram, where the rectangles, all of these grids is duplicated and were put on top of each other, forming rectangles. So as we've known, the first column is actually equals to all of the other columns. So by knowing the value of the first column, we just need to multiply by how many bars are they. That also equals to number of terms. So T1 plus T5 is A plus, using this formula, A plus 5 minus 1, D, common difference, times by 5 here, and divide by 2 because we duplicate them. So by comparing these two methods, as you can see here, why would I choose multiplying it one by one instead of calculating it with simple equation, simple formula? Okay, so let's go back to inquiry 3, where the point is I will compare this particular answer here with this one. So first thing is, what's the same thing between both of this equation, both of this answer? So I will write it here as 3 and 5 is number of terms. So Sn equals to n over 2. A plus a equals to 2a. Oh my god, sorry. Equals to 2a. And this one is n, so plus 3 and 5 is n, so n minus 1 d. Okay, so now let's compare it to the real formula. I'm sorry. Now let's compare it to the real formula, which is Sn n over 2 times first terms plus Tn. Okay, so here is the same Sn, sorry, Sn equals to n over 2. So here a is the first term. If I separate it from this to a, it can also be a here. And the ones that left is, sorry, the ones that left is a plus n minus 1 d. As we can see here, and try to compare it with the formula of Tn of the nth terms, it was the same, right? So here it will go as Tn. Now I would like to compare this one. I would like to compare this one with all the diagram that we have. This one in the bracket is actually first term plus last term. As we can see on the bars that I have drawn, on these two bars, this formula in the bracket is first term plus last terms. We can we can also write the formula as n equals to n over 2 times by first term plus last term. That's the point of inquiry 3 here, where we study the formula of sum of an arithmetic progression instead of just memorizing it, so that first thing is we can know where we should apply this formula, and the next thing is we can also memorize it. It will help us memorize it. So I hope my explanation will help you, and that's all from me. Thank you.
Okay, thank you, Christina. Good explanations. I love your preparation.
Thank you.
Okay, so we will hear from Ani Sophia to continue with the example of sum of terms. Okay. Welcome to Anis Sophia. Anis Sophia, please turn on your audio and video. Hmm. Ya. Awak tu. Okay, what happened here? Okay. Anis Sophia, are you ready? Anis Sophia, hello, Anis Sophia. Anis Sophia, are you ready? We cannot hear you. Anis Sophia.
Yes, yes, yes,
Okay, are you ready?
yes, yes, yes. I'm ready.
Okay. Why is the questions looks blur? Okay, Anis Sophia, your turns now.
Yeah. Okay. Assalamualaikum warahmatullahi wabarakatuh. I will be explaining on example 6. You can refer to the page 134 in the textbook. So here is example 6. Given that an arithmetic progression 4, 7, 10, and so on. Find A, the sum of the first 35 terms, and B, the sum of the first n terms. Okay, we will look at these questions one by one. We will look at A first. A.
Anis Sophia, wait, Anis Sophia, we cannot hear you. Yeah, we cannot hear you. We cannot hear you clearly. Looks like your audio is not clear. No, 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 we cannot hear you yet. Anis Sophia, we cannot hear you. Where is Christina? Christina? Anis Sophia, we cannot hear you.
Hello.
Yes.
Okay. Can you hear me?
A little bit louder. We cannot hear you clearly.
Can you hear me?
Yes. Okay, start.
Okay.
Yes, start back. Okay.
Okay. I will okay. Today I will be explaining on example 6. You can refer to the page 134 in the textbook. Example 6. Given that an arithmetic progression 4, 7, 10, and so on, find A, the sum of the first 35 terms, and B, the sum of the first n terms. Okay, we will look at both questions one by one, and I will go by question A first. The sum of the first 35 terms. The meaning of the sum of the first 35 terms is the total values of P1 plus P2 plus P3 and so on until P35. But here we are not going to list all the 35 terms. Instead, we are going to use the formula that has been presented by Christina now. Okay, so here we go. The formula is Sn equals to n over 2 in bracket 2a plus n minus 1b, where n is the term, a is the first term, and b is the common difference. So we are going to look the value of n is 35 because it asks us to find the sum of the first 35 terms. The value of a is 4 because here we are given the progression 4, 7, 10. So the first term is 4. And lastly, the common difference is 3. Why? Because we subtract the second term to the first term or the third term to the second term. For So here we go. We have all the values that are needed to be substituted in this formula. So lastly, what we are going to do is just to substitute the value of n, a, and b here into this formula. So we'll get S35 equals to n is 35 over 2 in bracket 2a, a is 4, plus n is 35 minus 1 times common difference b. So we just press our calculator, and lastly, the answer is 1925. So the sum of the first 35 terms for this particular progression is 1925. I hope you understand. Okay, let's move on to question.
Looks like that your voice cannot be heard very clear. Never mind. Just try. Yes, just try to explain. Okay. In the meantime, I will try to repeat what you have explained. Go, Ani Sophia.
So do I need to repeat?
No, never mind, never mind. Just continue.
I'm sorry for that. So I will continue for question B, the sum of the first n term. Okay, so what are we going to do is, just like before, we write the formula of sum of the first n term, which is here, and we also are going to substitute the value of a and b, but we are not going to substitute the value of n because the value of n is not given. Therefore, here we go, at n equals to n over 2 in bracket 2 times a, which is 4, plus n minus 1 times common difference, which is b. So the last answer will be n over 2 in bracket 5 plus 3n. This is actually the formula to calculate the sum of the first n terms for this particular progression. It means that whenever we want to find the sum of the first n terms for this particular progression, we just use this formula and just we just substitute the value of n here. So we will straight away get the sum of the first n terms. So the last answer is n over 2 in bracket 5 plus 3n. Okay, so that is the last answer. I hope you understand.
Okay. For the B questions, the question asks us to find the sum of the first n terms, right? So we just need to substitute the value of A, the first term, and D, the common difference. In order to find the sum of n terms, the sum of n terms means that you need to sum up all the terms, the first term plus the second terms plus the third terms until the n terms. So the answer in this form, you will get the answer in this form. So normally in the examination, the question will ask you to find the sum of the first n terms in the in this way. Okay, so hoping that everyone will understand this, and please try and you can ask Ani Sofia and Christina for this part. Okay, thank you, Ani Sofia. We will continue with our next presenter, Adam Haziq and Malik. Okay, Adam Haziq and Malik, please turn on your audio.
Madam, it's still Sophia. Sophia will be presenting example 6, 7, and 8.
Oh, okay. Just now. Okay. Sorry, Ani Sofia. Ani Sofia, sorry. Ani Sofia. Ani Sofia. While waiting for Ani Sofia, Adam Haziq, can you please present your first? Ani Sofia, are you there? Where is Ani Sofia? Ani Sofia. Ani Sofia.
Yes, yes, I'm here.
You have another example, right? Oh, okay. Sorry, Ani Sofia. Yes, you can
Yes.
continue with other example.
Okay. Okay, so I will continue with example 7. I will read the question first. The sum of the first 10 terms of an arithmetic progression is 230, and the sum of the subsequent 10 terms is 630. Find the first term A and the common difference B. From these questions, you can actually extract or come up with simpler sentence, which I have written here. Sum of the first 10 terms is S10, and the value of S10 is 230. So we have gotten the value of S10, which is 230. And next, the sum of the subsequent 10 terms. The subsequent 10 terms here actually means T1, T11 until T20. That the sum of the T11 until T20 is 630. So the sum of the first 20 terms is 630 plus 230. Why? Because 630 is actually the sum of T11 until T20. So in order to get the sum of the first 20 terms, we need to plus 230. So we will get S20 equals to 860. So here we have gotten two values, which is S10 equals to 230 and S20 equals to 860. I hope you understand after that. So we will move on to find the first term and the common difference. Okay, so here we go. We have these two values just now. So the question asks us to find the first term and the common difference. It means that we have
two unknowns, which is A, which we are going to find, and B, which we are going to find also. So this means that we need to have two equations because we have two unknowns. So we are going to form the two equations from these two values. So what we are going to do is like before, we will we will substitute the value of n from each of these information into this formula. So here we go. We will substitute the value of n from this first. So we will get x10 equals to 10 over 2 in bracket 2a, because we don't have the value of first term, plus 10 minus 1 d common difference. We also don't have the value of common difference. So here 230. Why 230? Because the value of x10 is 230. 230 equals to 5 in bracket 2a plus 90. So we just simplify this equation, and lastly we will get 46 equals to 2a plus 90. This is the first equation. And next, we are going to substitute the value of n from this information. So here we have n equals to 20. So x20 equals to 20 over 2 in bracket 2a plus n is 20, 20 minus 1 d. So the value of x20 is 860. So 860 equals to 10 in bracket 2a plus 19d. So we just simplify this equation, and we will get 86 equals to 2a plus 19d. So we already have two equations here, which is 46 equals to 2a plus 9d, and 86 equals to 2a plus 19d. So what we are going to do is we are going to use either elimination method or substitution method to obtain the value of a and b. So here I'm going to use the elimination method, which I subtract equation 2 to equation 1. Thus, I will get here 40 equals to 10d, and so I will get d equals to 4. So we already have the value of d. So what we are going to do is to substitute the value of d into one of these equations. So we substitute the value of d into equation 1. 46 equals to 2a plus 9 in bracket 4. So 2a equals to 10, a equals to 5. So here is the last answer. D equals to 4 and a equals to 5. Okay. Okay, I hope you understand example 7. So we will move on to example 8. I'll read the question. A swarm of bees started to make a new beehive. 2 hexagonal holes were made on the first day. 5 hexagonal holes were made on the second day, and 8 hexagonal holes were made on the third day, and followed on until the beehive is ready. Calculate the number of hexagonal holes on the 12th day, and B, the number of days if there are more than 1,000 holes made. Okay, we will look at the question one by one. We will look at A first, but before that, from this, we can actually have this information. Number of days equals to number of terms because, for example, I give you an example. Day 1 equals to T1, day 2 equals to T2, day 3 equals to T3, and so on. So here we have number of days equals to number of terms, or we can actually write it as Tn, and number of holes is arithmetic progression. For example, day 1, we have 2 holes. So the first term is 2, and day 2 is the bit make another 3 holes, and the total holes become 5. And day 3, the bit make another 3 holes, making the total holes become 8. Therefore, we will get this value. A equals to 2, and A is the first term, equals to 2, and common difference equals to 3. Here we have the important information here to solve the two questions. Okay, I will go for the first question. The number of hexagonal holes on the 12th day. So as usual, we are going to use the formula that Christina has explained as n equals to n over 2 in bracket 2a plus n minus 1b. So n, we have had the value of n, which is 12, and we also have the value of a and b. So we just substitute those values into the formula. So we'll end up with this. S12 equals to 12 over 2 in bracket 2a, a is 2 plus n minus 1, n is 12, and common difference is 3. So the last answer is 222. So the conclusion is the total number of hexagonal holes on the 12th day is
Okay, we lost Ani Sophia here. We lost Ani Sophia here. So I will invite our next presenter, Adam Haziq first. And Malik. Adam Haziq, are you the first presenter?
Yes.
Okay, Adam Haziq. Malik next, okay?
Yes.
Okay, so
Madam,
Malik.
can I start?
Yeah.
Okay. Now I will explain about example 9. So firstly, let me read the statement given from the example 9. Encik Suhaimi is a chicken breeder that has 1,500 chickens. He plans to sell 200 chickens each day. He gives food to all the chickens with the expenses of Rm 50 cents per chicken in a day. So, calculate the total expenses of the food spent by Mr. Suhaimi if he starts with 1,500 chickens until he is left with 300 chickens. So, from example 9, I have extracted some information given from the statement. The first information would be, given that Encik Suhaimi has 1,500 chickens, he plans to sell 200 chickens per day. The last one will be, the expenses of food for a chicken is Rm 50 cents per day. Now, the question is, calculate the total expenses of food spent by Mr. Suhaimi if he starts selling chickens from 1,500 chickens until he has left 300 chickens. Now, when we look at the word total here, you must be thinking of using this formula, right? But no, we still don't know the value of n. So we have to go through this formula, Tn, in order to find the nth term. Now, I will substitute the information given from the statement in these symbols. So Tn would be 300. Why? Because we need to find 300 is the nth term of what number? In order to find the day that he has only left 300 chickens. Next is A. A will be 1,500 chickens. Why? Because he starts selling his chicken with the first amount, which is 1,500 chickens. A is the first term in a progression. So 1,500 chicken is the first term of this progression. And lastly, D would be 200 because he sells 200 chickens per day, meaning that the progression decreases 200 chickens per day. So the common difference would be 200. Next, we substitute the values into this formula right here, and then we solve it in order to find the value of Tn. Thank you, madam. It's Malik's turn.
Okay, thank you, Adam Haziq, for the presentation just now. I'll be continuing with the implementation of strategy to the formulas given. Hold on, let me just change my camera. Okay, so given the information given, so we're going to use this formula here, right here. Hold on, can you see it? Yeah, the one mentioned in the previous group and by Adam Haziq just now. So we're just gonna fill in the formula. Oh, hold on, I wrote too big. Okay, so we're trying to find how many days the Inchi went from 1,500 to 300 chickens. So we're just gonna solve this right here, which will give us 700 and minus 200n. So we'll just take 200n to the start, just like how we usually do with algebra. So we'll end up with 200n here, and which will give us 1,400. 1,400, yeah. Then we should divide 1,400 with 200, which will give you the value of n, which is 7. So Inche Suhaimi went from 1,500 chickens to 300 chickens in 7 days. And with that given information, now we're going to count the total expenses of pardon me, the total expenses of the food when there are only 300 chickens left by Inche Suhaimi. And by that, we're going to use this formula. And you should, by filling the formula with the information we got from the previous equation, we should get that n is now 7. So 7 divide by 2. Hold up. In brackets, 2 times 1,500 plus 7 n 1 divide by 200, negative 200, which will give us the answer, which is you can either count this traditionally or use your calculator, and you will get the answer, which is 6,300 chickens. And from the question, we get that for a single chicken, the price of food cost is 15 cents. So take 66,300 chickens, divide by 0.5, we will get our final answer, which must be in ringgit because we're counting the total expenses. 3,150 ringgit, which is the total expenses of the food when there are only 300 chickens left. So as a conclusion, we know that n is n is 7, and the total n, which is the day, which is how many days Encik Suhaimi had, went from 15 to 300, and the total expenses of food provided for the chickens, which is 3,150 ringgit. That is all. Real simple. Straight from the book. Thank you.
Thank you, Malik. Thank you. So we are ready for the next presenters. Next presenters, I hope they will slowly explaining. Okay, so everyone can absorb. Okay, if you want to if your speed is too high, no one will understand. Okay, so please be slow and steady and explain, hoping that everyone can hear you clearly. Okay.
So now I will continue with 5.2. So now I will continue with 5.2, which is geometric progression. Geometric progression, also called as geometric sequence of number which differ from each other by a common ratio. Look at identifying geometric progression. There is a famous legend regarding the invention of chess related to series. According to the legend, a king from India wanted to meet the chess inventor to give recognition because this invention was interesting. The chess inventor only requested wheat to be given to him according to the following calculation. Look at the green box. It said that 1 grain of wheat in the first grid, 2 grain of wheat in the second grid, 4 grain of wheat in the third grid, and so on until the last grid. When the chessboard was filled, the total amount of grain given to the chess inventor was 1.84 multiplied 10 power of 19, which is equivalent to 1.2 metric tons. The calculation of the amount of grain can be obtained using geometric progression. For example, the sequence of 2, 4, 8, and 16 is a geometric sequence with common ratio of 2. So the common ratio is the amount between each number. For example, 2 multiplied 2 is 4, 4 multiplied 2 is 8, 8 multiplied 2 is 16, and so on. So from this sequence, the common ratio of this sequence is 2. We can find the common ratio of geometric progression by finding the ratio between any two adjacent numbers. Now let's look at inquiry 4. So inquiry 4, the aim is to identify geometric progression. It said that there are various bacteria in our surrounding. Bacteria can be found on unhygienic food, human and animal intestine. Bacteria can reproduce very fast and lead to disease such as diarrhea. The rate at which a bacterium reproduces is double at the same rate, which is every 20 minutes. A bacterium will become 2, 2 bacterium will become 4, and so on. If a human intestine has only 2 million bacteria, he or she will be affected with diarrhea. Look at number 2. Let's say if a type of food has only 1 bacteria. If you consume the food, estimate the time taken for you to be affected with diarrhea. This table is show that the number of bacteria reproduced. One box represents reproduction of the bacteria in 20 minutes. So it already give the value here until value of 8. So how to calculate this? So you see the number 1, you need to multiply 1 with 2 because it already say in the text which is a bacteria will reproduce double every 20 minutes. So you need to multiply each value with 2. So here the answer, I've already complete the table. So look at number 1. You said that 1 is equal to 2 power of 0. So you need to take the value of 1 and multiply it by 2 to get the answer. For example, I take the value of 8. I multiply the value of 8 with 2 and you will get 16, which is equal to 2 power of 4. And then you take the value of 16 and multiply it 2. And then you will get 32, which is equals to 2 power of 5. And you need to repeat this method until the value of reproduction of bacteria reach 2 million. For number 4, we will continue with Mimi Erdina at page 140. Madam.
Cikgu betul? Mana cikgu? Cikgu apa? Cikgu sini. Kakak tengah buat projek.
Maybe you can continue now. Mimi still in the car. Amani,
Yes.
can you help Mimi?
I don't prepare for her speech, madam.
Mimi, Mimi. Okay. Because Mimi still in the road. And now Mimi is missing. Mimi can hear us. We cannot hear Mimi. So, can you help Mimi explain this part until the example?
Oh my God. Okay. So number 4, it said that how long does it take for you to be infected with diarrhea? So I already show you it take 21, which is 2 power of 21 until it reach the value of 2 million of bacteria. So number 5 is said that determine the method to get the number of bacteria every 20 minutes from the previous 20 minutes is the value is constant. So the value is constant because the sequence is you must to multiply each value with 2. So the value is a constant. So number 6 and number 7 and number 8, Madam, I don't prepare because it's use the GeoGebra software and draw a graph.
Never mind.
Okay.
Yes. Explain the others.
Okay, from the result of inquiry 4, it is found that the ratio between any two consecutive term is a fixed number. Madam, can you scroll it down?
Okay, sorry.
It's okay.
This one?
Yes. So it is found that the ratio between any two consecutive terms is a fixed number. So the progression is called geometric progression. So look at the blue box. It said that geometric progression is a sequence of number where each term is obtained by multiplying a constant with the previous term. Madam, scroll it down. For example,
Okay.
okay, so this is the formula. If T1, T2 and until it's T number is the first n terms of a geometric progression, the ratio of the two consecutive terms is called the common ratio, which is represented by R. So for example 10, determine whether the progression below is a geometric progression. Give your justification. Madam, I don't prepare any calculation because Mimi have
Never
already.
mind. Just explain using this
So
solution.
using the function, so the ratio of first equals to 15 over 5 equals to 3. So you see, 15 divided by 5 is equal to 3. But 5 multiplied by 3 is equal to 15. And you have to comma it and take for the ratio of number 2, which is
Now,
15.
actually, we need to test the sequences to find whether the common ratio of each terms is actually the same. So you don't have to to say a comma, no need. You just say that we need to find the common ratio between two terms. So uh, first we need to find the first common ratio from T2 divided by T1. So you will get 3. Next, you need to test the the third terms with the second terms, 45 divided by 15, and you will get the same answer, 3. And test another terms, the fourth terms with the third terms, and still you get the same answer, 3. So if you get the common ratio of all terms, the equal common ratio, that is actually the geometric progression because the common ratio is
It's
the
the same.
same. Yes. Okay, continue with example 10b.
10b, so it already gave the common ratio. So you need to take T2 divided by T1 equals to 2. For the second common ratio, you look at T3 divided by T2 is equals to 3 over 2. So the common ratio is not the same. So this progression is not a geometric progression because the common ratio, which is represented by R, is different.
Okay. So remember, if we want to determine whether the sequences is actually geometric or arithmetic progression, we need to find either the common difference or the common ratio. You need to test both. You need to test both. Yes, yes. If you find that the common difference of the sequences is the same, then that is the arithmetic progressions. Okay. But if you find that if you use the T2 divide by T3, which is the common ratio, if the common ratio of all the sequences is not the same, different from each other, like the example 10b, then this progression is not a geometric progression, and you need to state the reason. Why? Because the common ratio is different. You need to state the justification, or else you will not be given the marks. Okay, so that's all for today, right?
FE group?
Yeah, FE group. But
Yes.
okay. So thank you, Amani, and other presenter. I will remove you now, but I cannot see Effie here. Okay, so I guess that Effie and the group will present in our next class. So please do the intensive practice for today's class. Page 136, self-practice 5.3, self-practice 5.4, intensive practice 5.1, and Amani's group, self-practice 5.5. Okay. Oh, sorry, Amani. So, we will stop our class now 9.34 sebab grup yang tadi tu cakap laju. Tapi tak ada masalah lah sebab orang lain tak ada tanya pun kat sini. So, please be prepared for our next online test. Schedule this week. This week, okay? Online test, chapter 1 to chapter, not online test. Peperiksaan pertengahan tahun. Wah. Okay, peperiksaan pertengahan tahun online. Using Google Forms. You need to choose the answer, the correct answer. You will be given B1 or B2 or total marks K1 or K2 if you choose wisely from the given answer. Okay, so until next class, thank you all Baidurians for coming to our class. So next presentation will be in 2 weeks times. This week and okay, next week. Okay, so you can leave the studio now. So So, Assalamualaikum. See you. See you again. Okay? Bye. Assalamualaikum.